Okay, in my continuing analysis comparing Barbosa and Leal's Earth Captor device to Tesla's special generator, previously I had described how the neon bulb of Barbosa and Leal qualifies as a substitute for the kinetic aluminum piston or disc in Tesla's special generator, according to William Line, or an electromechanical watt-hour meter, respectively. In other words, the piece of aluminum set into motion reflects something back into the system, and I think it's a disruptive influence, which creates asymmetry, and that asymmetry aggravates nature to correct the imbalance, and in the course of doing so supplies extra energy to the system from either earth ground, in this case of Barbosa and Leal, or common ground, in the case of the hull of a Nazi electro U-boat, or the chassis of a 1931 Pierce-era luxury car. Today, though, I want to add two ideas. One is that when we look at examples in history of DC-oriented transmission systems, they tend to have the hazard of developing parasitic transients to a much greater degree than does an AC system. And the two examples I'm thinking of, DC, are the telegraph systems of the late 1800s, or the second half of the 1800s, let's say. And they were powered by earth batteries, and they had a phenomenon they couldn't describe, but in modern day terms could probably be defined in terms of parasitic transient. That phrase came into being later on in the early 1900s when Thomas Edison set up his DC power system, transmission system, in New York City. And they had problems there too. And they had to call in Steinmetz to figure out how to fix it, but I don't think Tesla had those kinds of problems. I'm guessing, I could be wrong, but in my casual survey of history, that's what it looks like. That parasitic transients are more prone to DC systems, DC transmission lines, than they are to AC transmission lines. So it might help for this system, either Barbosa and Leal or Tesla's special generator, to be an AC-oriented system for safety's sake, to keep it managed. Otherwise, you get a wild stallion in there that gets a mind of its own. So that's point number one. The second idea is the nature of these coils. So let's zoom in here. To me, this electric keeper, I could back out a little. I've got a wind here. This electric keeper in here looks like the current coil of an electromechanical watt-hour meter, to me anyway. The secondary, and the primaries look like the voltage coils of an electromechanical watt-hour meter, to me anyway. Now they're both wired, at least the primaries here are wired as a voltage coil across the AC, so that would make this equivalent to the voltage coil on an electromechanical watt-hour meter. As far as the current coil goes, there's no analogy. Let's see, where could we find a current coil? Right here, the captor loop. There's our current coil right there, because it's in series rather than in parallel. It's hooked up in, the primary here is hooked up in parallel across plug number 2, the lead and the neutral, or excuse me, the line and the neutral, is connected across, as a shunt, you might say. So we need something in series to be the current coil, and it has to be heavy gauge. This is a lightweight gauge too. So far so good. And this looks like the qualifying agent because it's in series, because from plug number 1 the neutral of plug number 1. We have the 4 grounding rods separated from the 56 in series, one to the other, and then we have the captor loop. So, leading onward to complete its neutral line to power the load. So it looks like this captor loop is the current coil of what would be an electromechanical water ammeter. And it's also heavier gauge. This is 6 gauge, I believe, by comparison to 21 gauge on this primary coil over here. So for all intents and purposes, the electromechanical water ammeter has been replicated in Barbosa and Leal. But we have other elements in here. So we've got the aluminum rotating disc in place of the neon bulb. Now, if I haven't said it before, the neon bulb would be a problem. Any spark gap would be a problem in the electro U-boat, the retrofitted U-boats that the Nazis were using, because in a confined space with confined air, and then they have liquefied air tanks nearby, that could be pretty dangerous to have anything that sparks on purpose in your circuitry. So that's why Tesla went to the kinetic energy of a moving piece of aluminum to impart disturbance safely to the circuitry and not endanger the crew of the electro U-boat. So that's the only reason why we have aluminum in the story. Otherwise we don't need it. We can use a spark gap in the form of a neon bulb. Let's see, what else? So this represents the chassis, or the chassis of the Pierce era 1931 car, luxury car, or the hull of the electro U-boat, Earthground here. What else? So if we replace the neon bulb with a spinning aluminum disc, we could use this as our armature. But this is our armature from the electromechanical water ammeter. Put the disc in there to get it to spin, to get it to rotate. And of course, this single wire shunt coming out could attach to the spindle of the rotating disc. In my I-10 from 1910 General Electric, it's a brass spindle that the aluminum disc is positioned on, poised on. So that's it for today's attempt to draw analogous similarities between Tesla's special generator, the electromechanical water ammeter that most of us used to have just a few decades ago in our buildings and homes, and Barbosa and Leal, according to Clarence's replication. That's where all of this is derived from. So I'm just making an analogy between the 3 different systems. Is it 3 or 4? Pierce Arrow, Nazi Sub, Barbosa and Leal, and 4, yeah, and the electromechanical water ammeter. So 4 different systems. I'm drawing an analogy. And also the problem of parasitic transients, and why it's good to stay with AC and not go to something simpler like DC, which in its utter simplicity has no regulation to the power from getting out of hand, turning into parasitic transient, or giving rise to parasitic transients, because we have the steady beat of the AC sine wave generator from the AC inverter, helping to regulate the flow of electricity and keep things under wraps, so to speak, keep things regulated and safe.